Yo, I'm back. Well, I'm back because I think I owe it to my M24 class that I abandoned that I at least go over the papers. And I guess you guys too. But in case you don't want to hear me yap, then just skip ahead to me working on the question. But yeah, if you watched it in my last video last year, I said I quit. I quit teaching IB, and I did. And I'm so much happier. But I do have connections still, and I'm going to go through these papers. So normally I skip the SL ones. However, I checked out what my person sent me, and they didn't send me a lot of the SL short answer questions, a lot of the long ones. So maybe, I don't know. I'll just go through it all. Okay. In typical HL fashion though, the first couple ones are SL questions anyways. So let's see. We have Claire rolling a dice. She rolls it 16 times. And then we have a frequency table of her rolls. So we don't know how many ones and twos she scored. And then it says that the mean score is 3. And we're probably going to need to find P and Q. Yeah. So we're going to set up some equations. First off, you know that you rolled 16 times. So if you added up all the frequencies, then there should be 16 numbers. What the heck? Okay, so let's see. This is 9, right? And then I'm just gonna subtract it to the other side. So we got 7. One equation is not enough to solve for 2 variables, so we need a second equation, and that's where we have the mean score come in. To calculate mean in a frequency table, you just take the score, right? Because like you're supposed to add all of your numbers up and then divide by 16. But I know that there's 4 3s, so instead of doing 3 plus 3 plus 3, I'm just going to multiply these together and then add up all of the products and then divide that by 16. So I'm going to take P times 1, I'm going to add 2 times Q, 3 times 4, which is 12, 8 is 4 times 2, and then 6 times 3 is 18. So if I divide this by 16, this is my average, my mean of 3. Okay. And then let's simplify this and make it look a little bit nicer. What is this? This is 38, right? And then we're going to multiply the 16 with the 3. So then we'll have P plus 2Q plus 38 is 48. So P plus 2Q is 10, right? Okay, so now we have a system. And then I'm going to subtract the first equation from the second one so that I'll get Q equals 3, which means that P needs to equal 4. Because I know from this equation that P and Q need to be 7. Okay, nice. And then each of Claire's scores is multiplied by 10. So what is the mean final score? Oh, okay, so that's easy. If her mean score is 30, right, and then you multiply all the scores by 10, then you just multiply your mean by 10. It's only worth 1 mark, so that's probably... If you're ever doubting if it's like too easy, you should look at how many marks it's worth. And if it's worth 1 mark, then yeah, it's probably that easy. If it's worth more, then maybe you should be a little bit careful that you're doing what it wants. Okay, the next one looks like a log law question. So it says here we are going to say that log base 10 of a is 1/3, and then we will need to find the value of other things. And the way we do that is you need to have log base 10 of a show up so that we can say that it's 1/3. 1 over a is the same as a to the power of -1. And what's nice about this is we can use our log law to remove the exponent and write it as a coefficient. And so now we have our 1/3 show up, right? This is the 1/3. They told us it's 1/3. So for part A, this is -1/3. For part B, we have the wrong base, so you're going to do a change of base formula to base 10. This is in your formula booklet. So we know that that's 1/3. And then at the bottom, we know that this is 3. 10 to the power 3 is 1,000. So from here, 1/3 divided by 3 is 1/9. Okay. Yeah, SL question so far, right? This looks like an SL question. Arc length sector area question, probably. Let's see. Got a sector. Sure. The perimeter is 10. I'm just going to highlight this. Perimeter is 10. Area is 6.25. Okay, so the perimeter is the 3 sides added together. So we can make a formula. I don't even know what the question is right now. I'm just going to do this right away. So my perimeter, I know it's 10. And this is made from the arc length, which is S. This has an equation of r times theta. So this is r theta plus the 2 radii, these two. Okay, and then my area, I know is 6.25. Sure. This is really awkward. They usually don't give you decimals. I'm going to change this to a fraction. It's 0.25, so that's out of 4. 6 times 4 is 24. Okay, so this is 25 over 4. And then sector area is 1/2 theta r squared. So I'm going to say that this is 1/2 theta r squared. Unfortunately, we don't know any. We just got to call it r and theta. Okay, from here, now what is the question? I need to show that this equation is true. And so, like, where does this even come from? It comes from manipulating these two together. How would you do that? There's no theta in here. So I think what you're going to do is you're going to solve for theta in one of these equations. And then you're going to do a substitution into the other one. So let's solve for theta. I'll use equation 1. So if I do theta is, this would be 10 minus 2r divided by r, right? So this now gets substituted into here. And then we will not have theta anymore, and then they probably just like get rid of fractions and stuff, and then you'll get a. So if we do that, then now we have 25 over 4 is 1/2. 10 minus 2r over r times r squared. And then this r cancels with that r. This 2 and, well, this 2 and this 4 will divide. And then that's a 2 now. And then, yeah, we're basically done, right? Take this r, we're going to multiply it in. So we will have, I know this is messy, but hopefully you're following. But this is what we get in the top left, and then no fractions, right? So multiply this over here, and then you're basically done. Yeah, and then you'll get this. I won't do the rest. That's pretty straightforward. Okay, hence or otherwise, find the value of r and the value of theta. So hence means you should use this. You should use things in former questions. We want to solve the value of r, so that's fine. This is probably a factorable quadratic. Shoot. 4 is the leading. Is this 2 and 2 or is this 1 and 4? And then the middle is 20. Okay, and then 25, right? Okay. So for part B, you're just gonna factor this and then solve for r. So r is gonna be 5/2 centimeters. I don't think you really need to include units. They don't take off marks for that, from what I remember from mark schemes. And then we also need to find theta. So theta we had a formula for that we used to substitute it. That was this one in the green, 10 minus 2r over r. So theta is 10 minus 2 r over r. So let's see, this, so this is just 10 minus 5, which is 5. And then 5 will divide by 5. So this is 1. This is 1. And then 1 divided by 1/2 is 2, right? So this is 2 radians. Easy peasy. This looks like a calculus problem. Okay, let's see. We have two graphs. They're going to intersect at A, B, and C. Here are your two functions that are intersecting. We'll probably need to find out A and B, right? Or not A and B, A and C. They already told us what B is. Yeah, okay. Easy enough to do. If you want to find an intersection, you just equate the two functions. So cosine 2x is equal to sine 2x. And then, sorry, cosine x. And then there's not much you can really do because there's really only one option. This is a double angle on the left side, so we can call it sine 2x cosine x from your formula booklet. And then we're gonna move the cosine x over. And then we can factor out cosine. This is a very standard trig identity question. So just get used to doing something like this. Okay, and then from here, either cosine x is 0, so this gives us x is pi over 2, but we already knew that one, that was b. So the other two are from the 2 sine x minus 1, which basically is the same as finding out when is sine x 1/2. So this is special triangles, right? 1, 2, so this should be pi over 6, 30 degrees. So that one is A, right? And then we do need the second one, and that is in the second quadrant. So this is 5 pi over 6. Right? You have one answer here for positive sign, and that's pi over 6. And then you should have a second positive sign in the second quadrant. So the reference angle is pi over 6. So the actual angle is 5 pi over 6. Okay. And then find the area of R. Oh man, integrals. Okay. So the area of R is from here to here, from B to C. So they told us what the x value of b is. That's pi over 2. And then this is going to 5 pi over 6. Okay, and then, sorry, I just had to take a look. When you want to find the area between two functions, the integrand is the function on top minus the function on the bottom. So f is the one on top, and f is cosine. So here's your integrand. And you can just take the integral in separate parts. So integral of cosine of sine. You can plug in your angles. Actually, that's kind of awkward. Let's do it like this. Okay, so the integral of cosine of sine, and then you could do a u substitution here, right? Say this is u, 2x. For an HL paper, which this is kind of an HL paper, but I think this question is probably in the SL exam, you can just eyeball it if you know. A good gut check is, okay, take the derivative, right? And you should end up with here. I know that if I take the derivative of cosine, I'll get the negative sign. If I do the 2x, it'll be sine 2x. And then from the chain rule, I'll need to multiply this with a 2x. And if you, or sorry, multiply this by a 2 when I take the derivative. I don't have a 2, which means that there was a coefficient of 1/2 here. I don't really want to spend the time going over u substitution, so yeah. Okay, and then we do the fundamental theorem of calculus. Plug in our limits. This is so annoying. Oh yeah, and then one thing to be careful about, I did it here. There needs to be a times 2, right? In the cosine, so this becomes pi over 3. And this is, and then the pi over 2 becomes pi. God. Okay, and then you got to know your special angle ratios. We just said that this one was 1/2. So this is plus 1/2 times, I think this is negative 1/2. Minus, this is 1. And then this is negative 1/2, right? Yeah. Because this is negative 1. Just check your special triangles and stuff like that. Okay, and then we got to do some math. 1/2 minus 1/4 minus 1/2. So halves cancel. So negative 1/4? Sure. Good enough. And then next one, geometric sequence. Okay, write an expression for Sn in whatever form that they want. So this is your first term's 1, your common ratio is 10. You can pull this out of your formula booklet, but the formula for a geometric sum series is this. So we're just gonna put in our values though as we see it. Right? Plug these into the formula and then you get this. And then a and b are just integers, so this is fine. This is probably what they want. And then part B. Hence show that if we do S1 plus S2 plus S3 all the way to Sn, you will get this. Okay. So we need to use our thing in part A. We have a formula for Sn. So I'm going to write out S1 plus S2 plus S3 using that. So this is S1. And then S2. S3, and so on, up to Sn. Okay, and then we gotta simplify this. We gotta collect all of our terms together and get it to here. One thing is, these all are over 9, so I'm just gonna take that out. And then oh, I see what they're doing. Okay, and then we're going to add all of these terms together. And the way that we're going to do it is we're going to rearrange them, and I'm going to add all of the 10s together. And then I'm going to add all of the 1s or minus 1s together. So I'm going to add all the minus 1s together. And the reason why I'm doing this is because, like, you don't know how many terms there are, and you need to find a way to simplify it and collect it all together. And realistically speaking, the only thing you have are your series formulas. So take a look at what happened here. This is something that, you might not have noticed. When we write the terms of 10 together like this is another geometric series. So this is how we can actually combine these together. Where your first term is 10, and your ratio is 10. And then this, well, because these are all just negative 1s, we know that there's n of them, right? So what happens is that this is going to become 1 over 9. And then we're going to use the geometric series formula again. But of course this time u1 is 10, so now this is 10. And this is just minus n. Right? I have n of these, so it's just minus n. And then from here, we're basically done, right? Yeah. Yeah, we just need to combine these together. So first, common denominator, so this is 9n over 9. And then this 9 multiplies into the other 9s. And then you're done, right? That's what they wanted. 10 bracket 10n minus 1 bracket minus 9n over 81. I'm pretty sure this is what they wanted. I'm not going to double check. Okay, this looks... Yeah, okay. This is our first HL question. Well, actually, maybe this one is an HL question. This is pretty tough for an SL, to be honest. Okay, we have a volume of revolution. So the volume is essentially just pi r squared. Pi, your radius is the function, the value of the function. And then let's see, I'm going to integrate from 0 to root pi over 2. And then here's my function. And then I just need to show that this is the volume. So we're just going to do the volume of revolution integral. So this goes from 0 to, I think it was square root pi over 4? No, 2. And then, okay, while I'm writing this down, for people that don't know, these videos are completely just, I'm just raw dogging it. I have not taught IB or thought about IB in over a year. I just got these papers and I'm just doing it. So what that means is I'm gonna make mistakes, probably. Hopefully they're just small mistakes, so be nice and let people that are watching this know in the comments. But, you know, don't expect me to be perfect. I got a couple of hater comments calling me stupid for doing things the way that I did. But what do you expect? Okay, so the square and the square root cancel out. Like, that's nice. And then, oh, how am I supposed to integrate this? I could do by parts. Oh shoot, there's a squared here. Okay. See? I'm gonna make mistakes. Okay, that makes this a lot easier then to integrate. So, it's another u substitution. You could call this u. But again, if you know what you're doing, you can probably just integrate this using your eyes. So let's see, gut check. If I take the derivative of this, do I get this? And I think I do. So, good. Okay, plug in your limits. And then we're going to square them inside the cosine, so this becomes pi over 4. And then we're going to subtract, so it becomes a plus. And this is just cosine 0, right? Okay. More special triangle angle stuff. So this is 1. And then this is 1 over root 2. Right? 45 triangle, pi over 4. 1, 1 root 2. Okay, so what is this? We got negative pi over 2 root 2 plus pi over 2. And I don't think this is exactly the way they wanted it. Yeah, okay. So first, rationalize your denominator. So I'm going to multiply this by root 2. So the bottom becomes 4, and then you'll have a negative pi root 2 here. This needs to be a 4 as well then. So if this is a 4, then I multiply by 2. So this is plus 2 pi. And I think they factor out the pi, and they write the 2 in front of the minus root 2. There you go. Yeah. There you go. Okay. I should be nearing the end soon, right? Mathematical induction. Okay. What's nice about these is, like, you just kind of follow the steps. First, you check n and 1 and see if it's true. So I haven't even read the question. What am I checking? Okay, I'm going to prove that the left side, so n is 1, so 1 to 1 of this, which is just 1c1, which is just 1, by the way. There's only one way to make a combination of one item, and that's you have the item. And then we're checking the right side. The right side is 2c2 then, if n is 1. And then this is the same concept, right? There's only one way to select two items, or make a combination of selecting two items. So this is 1. Okay, so then next you make your assumption. So this is good. So this is going to be true up until some number k. And what you should do is you should write what this assumption is. And this assumption is from the question. Right? Yeah. So this is our assumption right now. And we will need this so that you can use it. You always use your assumption in the next step. So the next step is, now we're going to check out what happens for k plus 1. So on the left side, we have the sum, k plus 1, r equals 1, rc1. And summation ones are really easy because if your k thing is like here, because the difference between this and this is one extra term. You're just doing one more where the thing is k plus 1. So it's very easy to split up your summation and have your assumption show up. So we're going to split our assumption into the 1 to k plus the k plus 1 term. And this is just the left side. So now I can use my assumption and I know that this is k plus 1 c2. Right? I know this is this. Okay. And then you also need to keep in mind what you want. So on the right side, I guess I'll write it in red, whatever. I want k plus 2 c2. Right? If n is k plus 1, then I want these two things to be the same. The left side, this, and this. And what we're going to do is you need to use this formula for c. And then you're going to just manipulate this, and then it'll end up looking like this. So for the right side, if you put it into the formula, this is what you should get. Right? N is k plus 2, r is 2, so k plus 2 minus 2 is just k. And then we're going to do the same thing over here. Is this the last short one? I hope it is. I only really have time to do the short answers, and then I'll come back and do the long answers later. Okay, so we need to add these together. So they need a common denominator. Oh wait, hold on. I think I messed up this one. There you go. They need a common denominator. So first thing is, okay, this needs a 2. And this needs a k. So 2 factorial is literally 2 times 1. It's just 2. So 1 factorial is just 1. So this needs a times 2. This is a k factorial. This is a k minus 1 factorial. So if we just multiply that missing k, then this is the same as k factorial. So if you're a little unfamiliar, well, at this point in time, please recognize that that's k factorial, right? k minus 1 factorial times k is just k factorial. So now your denominators are the same, and they're 2 factorial times k factorial, so that's nice, because we do want these to be the same. And then let's look at what we have at the top. Okay. So this is why it's nice to write down what you should be getting, because you kind of know what direction you're heading in. I somehow need to write this as k plus 2 factorial. And the way we're going to do that is by factoring, because these are two terms and then they have a common factor of k plus 1 factorial. So if I factor that out, k plus 1 factorial, then I'm going to have the k and the 2 go in brackets. And just like what I said here with the red, this is k plus 2 factorial. It's k plus 1 factorial times an extra k plus 2. So that becomes k plus 2 factorial. And then you see you're done. Draw a little square. In math, that means that you finish the proof. These are the same. Okay, is this the last question? Damn it. Okay. Maclaurin series. We want to write the first two non-zero terms of sine x squared. Okay, in your formula booklet, you do have the Maclaurin series of basic functions, sine being one of them. I think sine is the odd one, so it's odd powers of x divided by odd factorials, and it's alternating signs. And then cosine is the even ones, starting at 1. Okay. So we're going to base our Maclaurin series off of that one. The only real difference is that this is x squared, right? So what that means is you just replace all your x's in the formula sheet with x squareds. And we only want the first two. So this is just going to be x squared minus x to the power 6 over 3 factorial. Right? X squared to the power 3. And then from there, I want sine squared x squared. So all this is, right, is that this is just... let me use a different color. This is just sine times another sine. Okay, and then we already know the Maclaurin series from part I for each one. And we just expand it out. Now, we only want the first two terms, and there will be 3 terms when we expand it out. So you don't have to do all of it. You will do the first 2 multiplied together, and then the inner and outer products. We don't need to do the last 2 if you want to save yourself some time. Okay, so if I multiply the x squared with the x squared, I will get x to the power 4. If I multiply the x squared with the... If I multiply this x squared with this x to the power 6, I'm going to get x to the power of 8 over 3 factorial, and I should have 2 of them with a minus. Right? I get one from this one, the inner ones, and then one from the outer ones. So there you go. Hence or otherwise, more Maclaurin for this thing. Okay. So The otherwise implies that you could just do this. We already know what this is. We found it in I. You can do the exact same thing for cosine, and then you're just multiplying the first two terms of this one with the first two terms of this one, just like what we did here. And then afterwards, you multiply in a 4x. That's kind of the long way. The short way is it says hence, and you're gonna try to use I. And the way you do that is they asked you for sine squared for a reason. And if you look at the format of this, you have a sine times a cosine, and then there's a 4 here, which means that there's a 2. There's a 2 here. So this is kind of a sneaky thing, and you kind of need to be able to see it. I'm going to rewrite the 4x as 2x, and then there's the other 2 split off, and it's going to be multiplied with the sine and the cosine. And what you can recognize is that this is a double angle identity. So this becomes 2x times sine squared x squared. And we already know what this is as a Maclaurin series. We just found it out earlier. Right here. And then we can just multiply the 2x in, and then, hold on, I don't know what the heck this song is. I'm going to change it. Okay, and then multiply the 2x in. And you're done. 2x to the power 5 minus 4 x to the power of 9. Yeah, that looks about right. Okay, last question, and then I don't know when I'll do the long answer, when I have time. Okay, let's see. You have a graph of the absolute value of x, the absolute value of x in an f. So you have this thing. And then we need to sketch the absolute value of this graph. Okay, just ignore this, right? This is just already graphed for you. We want to graph the absolute value version of this. So all that really is saying is like, these outside ones are essentially just saying reflect negative y. So this gets reflected like that. This also gets reflected upward. So do these little arms at the end. So anything that had a negative y value will be absolute. The absolute value is taken, so they're now positive versions. So graphically speaking, you're just reflecting upward or across the x-axis. Okay, so that's done. Oh yeah, and then of course, well, anything that was originally positive stays positive, so this is what you should have graphed. This like bumpy thing. And then given that f is an odd function, we want to graph f. Okay. Hold on, let me... Okay, this is the right half of the original graph they gave us. So one thing you need to know and understand is what happens when you take the absolute value of the x. This essentially reflects the positive... Oh shoot, my camera's covering. As a function transformation, this reflects the positive x across the y-axis. In other words, it makes it even. So in the black, I'll just get rid of this for a second. This is the right half of the original f. And then what we did to get the absolute value x graph is we just take this and then we reflect it over to get this part. Okay, so I already know what the original f function looks like, the right half, and then I need to know what the left half looks like, and for that they tell you that it's odd. So an odd function means that the right and left halves, if like you're splitting down the y-axis, they are double reflections of each other. So an odd function means that the right half and left half, I can just take the right half, I can reflect it across the y-axis, and then afterwards I reflect it across the x-axis, or vice versa, whatever order I actually did it in. So this is actually the left half of the function. This is an odd function. This is what it means. This and this are the same thing, but they're just reflected across the x-axis and then the y-axis. Right? Turn the blue one upside down and then flip it over here. You would get the red one. So this is f, and f is odd. And so you have this. Okay, nice. And then now, let's see, we have some integrals. The integral from 0 to 4 of the original graph is 1.6. So you need to use the fact that an integral is essentially an area. So they're saying that the integral from 0 to 4, so like here's 4. So they're saying that this is 1.6. Of course, this little bit is below, so this is negative. So when you add it with this one that's above, they're going to be subtracted. But it's still a positive number because you can kind of tell, right? This is a larger area. This is a larger positive area, and this is a small negative area. Okay, so we need to find the value of 0 to 4 of the original function. Okay. Oh, I should have just wrote it here. So, like I said, right? We know that 0 to 4 we know that this is 1.6. And then it's asking, well, what's the area from -4 to 0 of f? So this graph that I have right now. This area. And because of the symmetry, it's going to be 1.6, but because now the bigger hump is below the x-axis and this hump, the smaller hump, is above, and you know, because we flipped it upside down, essentially this is a negative area, a negative total area, but the like absolute size is the same. It's 1.6, but this should be negative. And then we need to go -4 to 4 of this. Okay, so we're adding the two areas together. Let me just draw this real quick. So this one is the absolute x one. And then we're going to add that to f. Okay. It's been ages since I used this tablet, by the way, so that's why my writing's kind of ugly. Okay, so we're going to add the areas together. So this one's kind of... it's kind of cute, I guess. So for visualization's sake, we're adding this area. So this is the first integral, this one, from -4 to 4. What's nice about this though is that we already know what these are. This is 1.6 on the right side, and we also know it's 1.6 on the left side because it's symmetric. And then the thing that I was saying is cute is this one, which is kind of silly why they're asking you to do it. Because we talked about this earlier. This is 1.6, and because this is odd, this side is -1.6. So the total area of this one, of the F part, is nothing. These will sum to 0. And you can see it, right? Like this little hump is gonna cancel out with this little hump, this big hump is gonna cancel with that one. So essentially, your integral, the total area between adding all these sections up, is 1.6 plus 1.6. Which is, you know, 3.2 or whatever. And then that's it, right? Yeah, we're done. Okay. I don't know when I'll do the long ones. Like I said, this is all just like... actually, it's not volunteer work per se. I'm trying to monetize my channel because I'm allowed to. So please, you know, disable ad block or whatever and give me some money. So thank you for watching, and yeah, I'll see you when I see you.